Good evening and welcome to tonight's NAPIT Trade Association webinar on temporary electrical systems. I'm Matt Freeman and we're joined here tonight at NAPIT by James Eade of E-Mech Entertainment Engineering, one of the industry experts for temporary electrical systems as well, sitting on the BS 7909 panel and helping to design the Premier Training Academy BS 7909 course. He's joined by Paul Chaffers as well, our Technical Events Manager, with us this evening to take you through temporary electrical systems. Maybe if you've not been introduced to it before, explain a little bit more about how this could be a business opportunity, what's involved technically with TES as well. And you will have your chance to ask your questions later on this evening. You'll see on your screen at the minute, there'll be a Q&A panel there, a Skype Q&A panel. All you need to do is pop in your name, pop in your question there at any point throughout tonight's presentation, and we'll get through as many of them as we can as we get through towards the end of this evening's presentation. But for now, I'll leave you with Paul and with James for tonight's presentation.
Thank you very much.
Thanks, Matt. Okay, so let's have a little look at what we're going to cover tonight. We're going to go through sort of a brief introduction of temporary systems. I'm going to get James to explain some of the finer detail, what the applicable standards are, the types of installations we see out there, some considerations that we need to look at, testing requirements and certification, and also what training is available. Okay, so quite often these systems, they're characterised by the fact that they can be readily disassembled and reused. Now, temporary systems apply to just about everywhere. So this could be, it could be railway works, it could be armed services, power companies, right down to like smaller events like village fetes, marquees, Christmas markets, broadcasting, and then the events and entertainment market, which alone contributes to 40 billion a year to the UK. Okay, so looking at the distribution, it needs to be flexible. When we get this equipment, we need to be able to see what's needed on site and be able to configure it in many different ways. Now, we've got to consider that things change. The weather can change, schedules can change. So we've got to have resilience built into this to be able to deal with it. And we've got to learn how to be able to manage that safely on site so that safety is not compromised. We're going to have different supplies to, that could affect the operation of protective devices. There's a lot of different characteristics that can, as well as the weather, the sunshine, the different equipment that's on site, it can all have effects on the operation of our devices. Timescales, they can quite often be short. They can be from hours to weeks, so we're going to look at that. And we've got to look at all the different types of suppliers that are on site and what the clients need. So temporary systems, they could be very large and complex events, such as this event, the Radio 1 Big Weekend. So I'm just going to ask James to sort of like just explain a little bit about what's in the pictures there.
Yeah, many of you might have actually listened to this on the radio or seen it, but Radio 1, it's a regular event for them. But there's a lot of infrastructure that goes into a big festival show like that, where you've got catering, production, concessions out front, as well as all the power distribution for the stage and everything. And if you look at the left-hand picture, what you'll see is this is actually underneath the stage itself and where all the lighting and power is distributed. And the two black racks in the foreground are actually two 72 channel 2 kilowatts of dimming racks. So each dimmer can dim 72 channels worth of 2 kilowatts. So we're talking quite big power. And then the racks in the back of the picture are all basically big distribution boards. So there's a 96-way distribution unit. So literally turn up on site, wheel them into position, tip them up into their operational position, take the lids off, plug it all together, and you're up and running. So you can build systems very quickly. On the right-hand side, you can see the containerized generators. And in events, we often run generators in synchronized parallel pairs so that if a generator fails, you don't lose the whole show. So each trailer has got a pair of generators running in parallel. And on the left-hand side, you've got two 800 kVA units, and on the right, you've got two 900s. One is just doing the outside broadcast, and the other is doing the lighting and stage power for video and sound and so on. So there's a lot of equipment goes in a very, very short timescale in that type of application.
Okay, thanks, James. So that's the sort of snapshot of large and more complex events. But the sort of principles of BS 7909 still apply to sort of what's more known as small and simple events. So, such as this marquee here, this could have a power supply for the bands to play, some lighting,
Beer tent, yeah, all important. So it's the same kit, there's just less of it. So you'll still have distribution units, you'll still have a generator, you'll still have lighting to rig and so on. So it's all the same cabling, same infrastructure, same hardware. There's just on a smaller scale basically, and not so much of it. So, but the need for management is the same, and that's one of the key things we'll come on to in a little bit.
Excellent. Okay, so the big question is, how temporary is temporary?
Right, One Love Manchester concert. Now that build started on a Wednesday after the tragic events at the Manchester bombing. They decided to do the concert. The button was basically pushed on the Wednesday, and everyone had to turn up then on site and actually start designing systems, putting them together. So the whole thing is erected in a matter of days for a show on the Saturday night. And so it's a lot of stuff goes in a very quick period of time. And you get an idea of the scale of it on the picture of the left when it's all being set up, and the video tiles you can see there in the different colours are being programmed. On the right hand side, you've got the power supply from the generator compound to the back of the stage. And it looks like a big bundle of cables, but each one is a 240mm supply, and you've got about 8 or 9 400 amp 3-phase supplies running from the generator compound to the stage itself. And that's a lot of cable, and believe me, when you're carrying it around site, you get big biceps because it weighs quite a lot. But in terms of the application, again, it's a very big, very high profile event, so it needs to be very carefully thought about and effectively managed to make sure that it works effectively. And the last thing, would be to have it going off air for power problems, because the power is the one backbone that runs through everything, really.
Sure. So the resilience has got to be built in.
Absolutely.
Okay, so that's a temporary event. It's gone up and it's back down within a day or two.
Yeah. Oh yeah. No, that will be on the trucks within a day, if not two.
Okay. So looking at a Western show then, we've got some examples there. The Cats musical, 25 years.
Plus.
The Lion King.
Now, again, when they develop the show and they go through the rehearsals, and it'll have a defined life at the box office, they'll hope it will last 6 months, and that's what the finances are based on, for example. Next thing you know, 25 years later, it's still going. So the person responsible for the temporary electrical system then has to think about, okay, when's it going to need inspecting? Who's going to check the kit? Maybe do the portable appliance testing on a periodic basis, all the light fittings and stage practicals. So again, there's an element of management that goes about it. But in terms of the question about how temporary is temporary, BS 7671 says that a temporary electrical installation is one that's erected for a purpose and then taken down when no longer needed. So there's no definition about how long it may last. Some temporary buildings may be up in location for a year or more while another building's being built, and a lot of the electrical installation and that would be temporary. So there's no defined period, but the key thing is the plan is to take it out and hopefully reuse it.
Excellent. Okay, so looking at the requirements of the wiring regulations, we generally apply them to electrical installations generally, but in certain cases they may need to be supplemented by other standards, and regulation 110.13 in the scope of the regs refers to this. And for temporary electrical systems, BS 7909 is the code of practice to be used. So quite often when you look at the wiring regulations, when we need to start looking at individual requirements of certain things, such as temporary power, we'll look at another standard. I just want to bring you in, James, to explain about this standard, the technical standard.
Yeah, technical standards for places of entertainment is administered and overseen by an organisation called the Association of British Theatre Technicians, ABTT, but it's also got input from the Chartered Surveyors Association and others. And with event venues, and this is quite important for a lot of members who might get called in to go and do some work at a performance venue, be it a theatre or a performance venue of some description, that there are requirements to make sure that the artistic integrity the venue is maintained when you're looking at the electrical installation. As a very basic example, you wouldn't put Running Man green exit signs at the back of a stage, because obviously that would ruin a show when you've got these lights coming on. So these things have to be thought about, and the application of the venue has to be looked at when you're thinking about the electrical installation and making sure that the electrical system is going to work effectively. So the technical standards for places of entertainment has requirements for that, amongst other things. You know, it covers disability access, heating and ventilation, and so on, but very much with that focus on it. That is also listed in the appendices of Appendix 1 of BS 7671 as well, as a suitable guide.
Okay. Okay, so what we're seeing here, the reoccurring theme is that management is the key. And
absolutely, because as you pointed out earlier, these systems are going to be used in different environments. You'll have a distribution unit that could be doing a festival one day, might be doing a wedding the next in the marquee. So someone needs to think about how the system's going to be used, the environment it's being used in. And although BS 7909 is very much focused on the management, it requires people to design systems in accordance with BS 7671, because it's a perfectly good design guide, has been for many years. It's 135 years old-ish, thereabouts. So, you know, the fundamental principles are still very much valid. But the 7909 takes over and says, well, if you have a system that's designed effectively, this is how you manage it, and this is the type of equipment to use and how to assemble it in a robust and functioning manner. So one of the key themes is it places a heavy reliance on equipment testing, so that we know when all the equipment turns up to site, all the extension leads and distribution units, they're all in good order. They've been checked, polarity, insulation resistance, and so on. And the other aspect of the management is that it helps people comply with the management regulations and the construction design and management regulations, CDM, which now apply very much to the events industry. So if you've got competent people managing the temporary electrical system, it helps the production comply with their requirements under the appropriate parts of the law. In order to do that, BS 7909 introduces the concept of the senior person responsible. And that person is an electrical duty holder who knows how to manage that system. And that level of competence will be variable. For someone doing very simple village fete, for example, it might be a basic level of electrical knowledge, but you wouldn't have that person necessarily putting together a big festival site where a much higher degree of knowledge and skill is needed. So the competence of the senior person is scalable to the event that's being undertaken. And BS 7909 is written carefully in that manner. It also takes off as a standard from where BS 7671 leaves off. So it provides more guidance around the selection of cables and equipment, the type of connectors to use. Many of you will be familiar with what we call a C-form, that you might know as the commando type of industrial connector. They're widely used in events and entertainment. And over 125 amps, we go on to big single pole, what we call power lock or power safe connectors. And by using that pre-assembled equipment, it enables us to put together systems very quickly that are going to be effective and work functionally. So that's the key underlying themes: right kit, good kit. Then you'll end up with a system that's going to be inherently reasonably safe.
Okay, thanks, James. Okay, so as James has just talked about how important it is to use a good supplier and to ensure that the kit turns up on site, it's been pre-tested. It's not like our traditional fixed installation wiring where we've got time to do all of our R1, R2 dead tests. Absolutely. And initial verification, because by then, you know, the event would be over. We've got to get the equipment, we've got to erect it fast, so we need good equipment arriving on site. I think you'd all agree that the picture on the screen there shows a fairly good condition set of equipment. Now we tend to refer to these boxes as distros in the industry, don't we, James? But it's short for a distribution unit.
Box, distribution board. But the key thing is, like you said, it's all been checked back at the warehouse. So I know that those extension leads, the insulation will be good, the continuity will be good, polarity will be good. So all of these things I don't need to repeat on site, because I can rely on the hire company that I've rented it from being diligent and doing those checks for me, so that I know that the kit is in good order.
But sometimes we're on site and we've been let down, the supplier's not been as good, or the kit's done a heavy you know, a heavy job the week before and it's turned up looking like this. The important things, we've got to take action.
And this is where it's important to make sure that you've got people who've got good electrical skill. So people who are competent and familiar with you know, how the electrical distribution works, so you can take things like this and make it safe, which is the key thing. May not be perfect, but the key thing is it's always got to be safe. So it's having that skill to be able to do that in the field.
Okay. So looking at the on-site challenges, we may have things like the picture on the left there. We're looking at cables, so it's a rubber cable. It's ideally you would want to route it around the edge of fencing or around the edge of the marquee, so it's not trodden on. But occasionally you may have to across a walkway to get to a burger van or something,
which is really common. And traditionally, as I think you said earlier, was, you know, you'd bury it to about 600 mil.
Yeah, when we were talking earlier, you know, the viewers would be familiar with 600 mil guidance for a trench and laying sand in and, you know, backfilling it with sand or sifted soil.
Obviously, we wouldn't have time to do that, you know, because by the time you've got that level of excavation in, it'll be time for the show. So the recommendation in the IT guide to the subject says approximately 200 mil. So it's deep enough that it's not going to suffer mechanical damage in use. But one of the key aspects about trenching cables in like that is that you know where they are. And so it's a relatively controlled environment, which a cable that's buried under the road, for example, people will long forget where it was actually buried. So an environment like that's there for a short duration. So the cable just has to be sufficiently mechanically protected. And so also hence the reason for the rubber cable, because it has better mechanical protection.
Good. Then sort of just to bring in the RCD there, you know, we could have a generator turn up on site and it has been, you know, it's come out of the generator yard, set to 30 milliamps. Is that always going to be suitable?
No, because what tends to happen is a lot of modern loads, things like in LED lights and similar, the power supplies leak a little bit of current. There's natural leakage, which is perfectly acceptable, and it's a design aspect of the filtering components in them. But what that means is that if you have 20 of these lights and you connect them all onto that RCD, that amount of leakage will push the RCD over its operating limit, and it will keep nuisance tripping, basically. So it's really important to make sure that there's effective selectivity in the distribution, so that at the source you have an RCD that's rated higher, say 100 milliamps or 300 milliamps. But the crucial thing is it must have delay built in, so that if there's a fault, we disconnect the RCD on the final circuits closest to the fault, not the ones at the source of supply. Because to put it bluntly, you don't want someone plugging in the kettle backstage, tripping the generator and everything going dark. So we want the RCD at the supply, at the final circuit to actually disconnect before the rest. That means you need delay built into the system.
It doesn't differ from traditional understandings of selectivity or what used to be discrimination. It's just that some of the viewers may not be familiar with adjustable RCDs and time delays of
you know, there's an application for such devices in events, because quite often you won't actually know what the loads are, and so you won't know what the leakage currents are. So there is an element of setting them up on the hoof. And so it's important to be able to measure these things, or at least set them to reasonable levels that you don't get unwanted operation.
And the senior person responsible would be responsible for ensuring that the correct coordination was in place.
Yeah, and also just quickly on this point, one thing BS 7909 also talks about may sound like electrical heresy, and that's turning RCDs off. Because in an event, you have to think about the application of crowd control, so that if you've got 50,000 people in a field and an RCD trips, then you might have a crowd control issue as 50,000 people start stampeding for the exits. So BS 7909 recognises that and says in some situations it may actually be safer to turn an RCD off to avoid that level of risk happening in an environment where you've got a lot of people.
And that would be quite a new concept to some of the viewers here today.
It was
for bypassing an RCD. So
under very controlled circumstances, there is a place for it, but it has to be done after a proper risk assessment.
Excellent.
Specific from that event.
Okay. So moving on then. So we've talked about this pre-testing. So the equipment should be fit for purpose when it arrives on site. The equipment suppliers should have inspected it prior to delivery on site. therefore the person responsible on site needs to check it. Visual, it's going to be a visual check. You're not going to do all your continuity checks. You've assumed that's done. Should there be test records that come with it?
Well, I think
labels.
I think most. It depends on the hire company. Many hire companies might use a coloured cable tie. So when you look at an extension lead, you'll see a purple cable tie, which means that it's in its current period. And they'll say if it's orange or green, don't touch it. Some might just have green labels, traditional equipment tested labels on.
Sure.
Other companies will say, here's a website, there's all the kit that's been delivered to site, go and have a look at our server and check what records you like. So every company approaches it in a different manner, but the key thing is you want to make sure that your supplier is delivering you equipment that's in good order.
Okay, so as we've said there, each time it's set up, it should be treated as a new system.
Yes, and this can be a bit of a problem, particularly on tours where we might be going from venue to venue. Technically, although it's the same kit, it's the same hardware, and it's the same distribution, every time you go to a new venue, it's classified as a new installation. And there are reasons for it, not least that at each different venue, the characteristics of the supply are going to be different. So where I might have a socket on the wall that I connect my distribution to, in one venue, the earth loop impedance might be quite low, the next venue could be quite high. So it's important to make sure that the system is checked to make sure the protection is going to work at each different venue.
Okay. The issue is, do we need to test every circuit? Is there time to test every circuit?
No, and I think that will come on. That will.
We're gonna
wait till the next slide.
We're gonna zip through some of the requirements for testing. So BS 7909. Easy for me to say. Easy for me to say. It gives requirements and it talks about some of the basic principles that are required.
It does.
Okay.
And so, yeah, as you've got here, generator earth electrodes. With a temporary supply, they're often running off generators, and we'll touch on the new IT guidance on this in a minute. But the key thing is the generator earth electrode has to be of a low enough resistance to enable the output device on the generator to work if there's a fault to earth. Now, if that was 100 milliamp RCD, we only need a small current flowing to trip the RCD. So the earth electrode resistance can be quite high. But if you didn't have an RCD, then it would need to be much lower resistance to get enough current flowing. So we need to make sure that the earth electrodes are effective.
Okay.
So that does mean testing them. The RCDs, again, we'd want to check that they're working effectively. Now, quite often the variable ones will have a test feature on them, so you can actually make sure that they are operating effectively. And BS 7909 encourages at the very least that you go around all the distribution units pressing the test button on the RCDs to make sure they're functioning, because mechanical damage does happen, and particularly on 30 milliamp devices which are being used for protection against electric shock and additional protection, it's important to make sure that they haven't fallen apart on the way over.
It's quite a harsh environment as well, and it lugging the gear into the event, out of the event,
they get thrown on trucks and everything, so you know they are subject to wear and tear. And also, so it's important to do a few checks on final circuits and some distribution circuits. As we pointed out earlier, because all the equipment is tested, then we don't necessarily have to test all of the distribution, and that's where BS 7909 has a modified testing regime to take this into account. So that if you imagine basically like an ordinary 4-way block 13 amp sockets, if you test one outlet, then you can reasonably assume that you're going to get similar numbers on the other 5 outlets if that extension lead has been tested before it came out from the warehouse. So we take that principle and apply it to the bigger distribution, so that if I've got 10 extension leads running to a particular place, if I get good results on one, then I'm likely to get good results on the other. So the senior person responsible would look at the design and choose those crucial test points,
the relevant points.
Absolutely. And so if they're happy that the protection works at those locations, it's likely to be effective throughout. So it enables testing to be done in a quick fashion.
And there's a lot to be taken on board, like just looking at the picture on the right there. You know, it's a distribution. We have requirements for up to 32 amps for RCD, 30 milliamp RCD, but of course that's only for domestic. We've got the risk assessment for
absolutely
other than a domestic.
Yeah, no, I'm glad you brought that up actually, because the requirement for RCD protection on the 32 amp circuit, the intent is one for it's going to be used as a final circuit for people who are going to be holding the equipment and so on. We might have a 32 amp 3-phase distribution circuit, So we wouldn't necessarily apply the 30 milliamps to that because it might not work. And so that's where it's important to remember in the wiring regulations a requirement for selectivity and to make sure that we don't get unwanted operation of the RCDs.
Okay. So as a minimum, we want to check polarity, output loop impedance tests, and they should be done at the relevant points as we've just discussed, and where relevant, phase rotation.
For the most part, we tend to split things down into single phase loads, but quite often we will have three-phase appliances like a stage lift or a three-phase air conditioning unit. And obviously, if you've got a phase issue, then you might blow up the equipment. So it's important to make sure phase rotation is checked where it's appropriate. The other thing is we need to do the short circuit current as well, because with the long extension leads, it's easy to forget that if I've got an RCD protected circuit, the earth fault loop impedance can actually be quite high. But if there's a short circuit, then we can give rise to the risk of fire. So BS 7909 requires short circuit current to be checked as well.
Yeah, because the RCD will only be there for, you know, an earth fault.
Absolutely.
We've got the image there, the cable's been damaged.
And this is precisely what happened on that particular event. The cable was running across a walkway and people hadn't provided adequate mechanical protection, driving over it with their trolleys and everything. And even the rubber, although it's got good mechanical resilience, it's not magic. So if you keep crushing it, it will eventually fracture. And that's what happened there. Was the rubber fractured, two conductors came into contact and there was a big bang. But because it wasn't an earth fault at the time when it originally happened, no protection worked. So it just sat there smoking and fizzing and popping. So it's important to make sure these things are thought about.
Okay. So BS 7909 requires that tests are carried out at the first intake switch unit and that enough circuits are tested, okay, so that you can satisfy yourself.
Yeah, so as we pointed out, the intake switch unit is an old TV term, actually. So it's basically the first distribution unit you get to from the source of supply. So if you have your generator, first distribution unit, that will be the ISU. And as we've seen, because we might have hundreds, if not thousands of circuits running around the place, you can't go and test each one individually because it would just take forever. So that's why the senior person needs to look at the design and decide which parts of the distribution he wants to test to make sure that he can satisfy himself the protection of work.
We can see from the stage lighting there's many lights. So if you've got, say, 5 or 6 lights all fed from the same distribution unit, and all the cables
all
are the
coming
same
up
length.
the same multi-core, all the same length, then if you get good results on one, you're likely to get the same results on the other. But I can only say that if I know that the kit is in good order and those extension leads are all checked when they turned up. So that's the recurring theme of BS 7909 is the kit, when it turns up to site, must be in good order.
Good. So, you know, just a quick one here. I'm a bit concerned about the time because we want to leave some time for questions at the end, but I just threw this one in there. We've got the wiring regs that talks about premature collapse of cabling systems. It doesn't say whether it's in escape routes anymore. It can be anywhere. Would we need to worry about it there?
Not in this application, no, because on the stage, if there was a fire, the sides would melt and you'd be able to get access from all sides. So, but it's important if you're in a theatre or an event venue where you might be running cables over doorways and things to think about the application of that new regulation in BS 7671 and say, if there was a fire tonight when we've all gone home and the fire brigade were trying to get through the place, you know, are they likely to get caught up in any cabling and just be a bit conscious about how you route the cables? And
so even though it's temporary, we still need to worry about that entanglement issue. Okay. So we kind of sort of we're drawn to a close, and we've got some images there of the NAPIT temporary electrical systems certificate, which is based on the model forms in 7909. Now, the problem is a lot of the traditional forms we use, like an electrical installation certificate, is just not suited to you know, temporary environment. So as James has spoke about some selected testings, it can be recorded on a form.
Yeah, absolutely. So there's a lot of similarities between the BS 7909 form and the BS 7671, but obviously just less information. So there's details of the characteristics of the supply and details of the protection, and also the schedule of test results. And in any inspection and testing, that's the key, because that's the real meat that tells you that it's going to be safe, because that's the evidence, the real
That
proof.
you've carried it out.
Yeah, so that's a key thing to make sure it gets filled in.
Okay. Now, one of the things that we've developed is a Sitting Guilds accredited program for training for you guys, anybody who's interested in getting in this. There's 2 courses that run. There's a 1-day course, which is really based for people that have already sort of been working in this industry and already have a previous qualification. So it says a 1-day update. But there's a 3-day course which covers the whole thing in its entirety. So I'm just going to get you to just briefly.
Yeah, the 1 day is for those who've done. There was a predecessor to this course called the Creative Skill Set Certificate, and for those, there's about 1,000 people who've done that, or over 1,000 actually. And for those who've done that, that counts as credited prior learning, so they only need to do the 1-day update. But if they haven't got that certificate, then they need to do the full 3 days.
Full 3 days. Now, the business opportunity, I guess, is if event production was looking for, competent technicians, they could, there'd be no good saying, oh, have you got an 18th edition, or have you got this? You need something relevant to temporary systems.
And so this course is designed to teach people the application of BS 7909 and 7671, how they work together. And also it covers guidance not covered in either standards, like the new generator guidance issued by the IET and so on. So it's all very much geared towards events and entertainment. And what it shows to clients and production companies is that you have an understanding of what the requirements are and how to manage them in them.
Yeah, we've got a situation where we've got many technicians, good technicians working in the industry, but they may not be familiar with testing and inspection and the electrical principles, but they've got the understanding of how these events work. And then we have the other side where we have electrical contractors and that are very good with their test and inspection skills, but need to learn a bit more about events. So this is where this course could create an opportunity.
And so it's amalgamating the two and helping people understand how the industry works, how to apply those requirements,
whilst raising the standards in the industry for testing and inspection and the like. Okay, good.
Design as well.
So that program is available through Premier Training Academy, and that's just some of the dates that we've got, upcoming dates. Now, if you're looking for any more information on this, James is the author of these 2 guides there. So if you can just give us a quick...
This isn't a sales pitch, by the way.
No,
introduced on my behalf.
The thing is, if you are looking at purchasing 7909 from BSI, it's quite expensive. Okay, there's an alternative with using these guides where you can have it explained in plain English. Is that correct?
The guidebook on the left, the original guide written back in 2014, that takes the BS 7671 and BS 7909, and it's quite a detailed guidance and explains very much in detail how to apply both standards effectively and how to design temporary systems, and also what to look out for, because things like power quality and so on is becoming quite an issue now.
Sure.
As we go down the energy efficient route. Whereas the guide on the right is basically, it's very similar to the IT's on-site guide in terms of spiral bound A5 format, but instead of being aimed at domestic installations, very much aimed towards temporary events. So there's a lot of pioneering new guidance in that on generators that doesn't appear in any British standards.
That's literally been released this week, isn't it?
It was hit their warehouse last Thursday, I think.
Okay.
And I still haven't seen a copy. So hopefully I might see one soon.
Okay, so that sort of brings us to the end of that presentation, and I'm going to ask Matt to come back in now with any questions you've emailed across.
Yes, waiting in the wings. Thank you very much, James. Thank you, Paul, as well. Very interesting presentation over the last half an hour or so. And thank you if you've sent your questions in already through the Q&A box we've got on screen at the minute. There's still time to get a few more in as well. So if you've got any questions about anything covered tonight, then do send them in the next few minutes. We'll get through as many of them as we can. We'll start with this one to do with Arctic cables. I mean, just put simply, can you use Arctic cables?
Arctic Blue? Is that what referring to the question?
Yeah. One of the things with Arctic cable is basically it's ordinary plastic cable. It's no different to an extension lead you can get from being here or similar. It doesn't really have any special mechanical properties. In fact, actually, manufacturers quite often put plasticizer in to make them more flexible at low temperatures, which is lovely when you come to coil it up on a cold day. But actually, what that does is, from a mechanical protection point of view, is when it's nice and warm and sunny, makes the plastic more pliable and so more likely to get damaged. And really crudely, if I stand on a plastic cable when it's hot, it'll squash and stay squashed, whereas if I stand on a rubber one, it'll spring back afterwards. So mechanical protection in temporary events is afforded by using rubber cables. So HO7RN types are specified, as they are actually in quite a few places in BS 7671.
But I guess it depends on the type of event. You know, if it was just a very small and simple church fete, for instance, and they wanted an extension lead from this side of the stage to that side, it was indoors, it was only there for a day, an Arctic cable may be acceptable.
And it'd be treated like any other plastic cable. The key thing is you need adequate mechanical protection to make sure that it doesn't get damaged. And because of the nature of temporary events, extension lead might be in a muddy field one day, might be up in a lighting rig the next day. So it's easier to use rubber cables because you know that they'll be effective in all applications.
Sure.
So most rental companies now will issue rubber cables. Another thing to avoid is the SY, that flexible armoured cable, because that's not designed for this application. And technically doesn't apply with BS 7671 either, actually, but that's another story.
We've talked a lot about sort of the British standards and things this evening, but is there a difference if you're working on foreign installations? Things like, Disney on Ice being given as an example here, that's sort of a foreign installation. They maybe work by their own rules for their kit and maybe not have the same safety regard. Does that change how you work at all?
If you're touring around the world, BS 7671 follows a European standard very closely, actually. So if you're following BS 7671, you're likely to comply with requirements in Europe. Now, going internationally, the European version is harmonized internationally. So the basic safety principles are the same. So if I'm using automatic disconnection with RCDs and similar for my method of protection, that's the same here as it is in middle of Africa, for example, or Dubai. But each country will obviously have its national requirements, and so you need to be aware of those. So, America in particular and Canada have requirements for temporary electrical installation. So it's important to appraise yourself of what the local regulations are. But as a basic safety measure,
the general rules apply. Yeah.
And so it's if you're following BS 7671, you'll achieve a degree of conformity with wherever you go. Obviously, national countries have their own national foibles. We've got 13 amp plugs. They have Schuco's in Europe, but it's like you say, fundamental rules still the same.
Okay. Is it right to understand that pre-tested equipment, once it's assembled to a whole, does that then not require any further testing? And also, what paperwork do you have just to prove the safety of that equipment? Is there any certification you go through?
Answer the first question first.
Yeah.
If I have a load of tested kit and assemble it together, will it be safe? Answer no, because if I have 10 metre extension leads, all perfectly good, perfectly safe, tested, plug them all together in a long chain, have a fault at the end, no protection will work at the source. So you can plug together a system in an unsafe fashion, and that's again why BS 7909 encourages people to think a bit more about the design of it. So tested kit plus tested kit does not equal a safe system. You still need to think about how the protection works and how things like impedance of extension leads and so on will affect that protection. And the second part of the question was, remind me again.
That's absolutely fine. It's not a memory test. In terms of those sort of situations, what paperwork or maybe certification would you have to prove the safety?
BS 7909 suggests that you should check that the supplier of the equipment has got appropriate pack records. Now, most people, when they do appliance testing, will record results of tests of polarity, continuity, insulation resistance, and so on. So that would be your paper trail, would be the supplier of the equipment giving you that information, which I hope answers the question effectively.
Okay.
So then, sorry, just quickly, when you get to site, you plug it together. You just need to make sure the protection works. And that's why we have that cut down testing regime.
Yeah. How should you deal with testing a final lighting circuit that's fed via a thyristor dimmer? Excuse my pronunciation.
No, it's actually spot on.
RFI filtering.
Yeah. Again, dimmers. You'd have a supply going to a dimmer, which obviously dims the light going up to the light fitting itself. If you connect an ordinary multifunction tester or any loop tester to such a device, there's two ways of doing it. One is to turn the dimmer on, so it's conducting for 100% of the cycle, but that will quite often need a load lamp, something to help it conduct. So you can then do the test. The easiest thing is just to bypass it. On many dimmers with a patch bay, you can just do a hot patch. So you just patch it onto a hard power circuit so that you bypass the dimmer electronics, to give you an idea about the loop impedances. Because a lot of meters will see the little delay in a zero crossing on the mains waveform. When it goes through zero, you get a little gap, and many meters will see that as noise on the supply and don't like it and won't test. So hence it's easier to either try and get it to conduct the full time or just bypass the dimmer altogether.
Okay. How do you determine what extraneous conductive part needs bonding or supplementary bonding? There's an example sort of given here about an extraneous conductive structure in sort of close proximity around arm's reach to a structure with no current carrying equipment. So if you're bonding or supplementary bonding, how would you test that for touch voltage?
There's I wrote about this in the IT's Wiring Matters, actually. If you look at the last issue, an extraneous conductive part introduces earth potential, and the danger is I might be touching a faulty appliance at the same time as that metalwork. And what we're looking to see is, if that's the case and this metalwork is earthy, that we connect the two together, so we limit any potential difference. So if I've got a stage structure here that doesn't have any electrical equipment, but I can hold on to that stage structure while fiddling with something electrical on this one, if that touch voltage is likely to materialize in the event of a fault on the equipment, then you need to bond them together. In order to test whether you need to, in order to test if something is an extraneous conductive part, if you get a multifunction tester on the continuity range on a 200 milliamp test, it can't be a low current test like you might find on a multimeter. You would go between the earthing arrangements of the supply, so the earthing terminal of the generator, for example, and the metalwork in question. And if you measure less than 22,000 ohms, then it needs to be bonded. And if it's more than 22,000 ohms, that's not sufficiently at earth potential to give rise to a serious electric shock. So that's also, you'll find that in IT's Guidance Note 8, but also the original, or both guidebooks actually, from the IT on temporary power. That's explained, but like I say, the key thing is you're limiting the chance of a potential difference between earthy metalwork and something that might be under fault conditions.
Yeah.
So it has to be simultaneously accessible. You know, if the stage structure's over there and I can't touch that and that at the same time, then that's not an extraneous conductive part.
Yeah. This one, it sort of also follows on a little from the RCD stuff we touched on in the previous webinar. So if this is something that we can't get through entirely now, we'll get an answer later on and we'll pop it up on the NAPIT forum. But to do with RCD selectivity, we've previously talked about requirements for upstream RCDs to be equal to the type of downstream ones. So does this mean the generator RCD or the ISU RCD should be a type A, F or B type time delay unit to allow for the inclusion of new RCDs downstream?
The type A, AC, F or type B depends on the loads connected. Generally, type AC would be fine on the final circuit, but upstream there'd be at least type A, if not type B or type F. Type F, particularly when you've got machinery, equipment and so on, where you might get quite a lot of noise on the supply, noisy DC components. So the discrimination you'd build up by having BS 7671, the 18th edition, now recommends a cascade ratio of 3:1 for the RCDs. So if you've got 300 milliamps at the generator, you then go down to, say, 100 milliamps at the ISU, going down to 30 milliamps on your final circuits. So you've got a ratio of 3:1 built in the system.
That's for milliamp ratings. This types of devices.
Types doesn't matter. There's no requirement. But what you've got to be aware of is if there's a fault or if loads are creating DC components and you've got a type AC at the source, then that type AC will be completely deaf to any faults that might occur. So it depends on where the RCD is and the distribution and the connected loads. But what you have to remember is that leakage currents will go all the way through the distribution. So if I've got a variable speed drive generating DC components here, that's going to affect everything in that distribution all the way to the source. So you'd need to choose
coordination. If you needed a type A down there, you need a type A up here. because the characteristics are still going to affect it in the same way.
Absolutely.
I think we got there in the end.
That's right.
We're getting towards sort of the end of the time really, but I know Paul, you mentioned some events that are coming up and things, but also mention of Plaza Focus in Leeds, which is coming up pretty soon, isn't it, as well?
Yeah, I think it's in May, is it? In May?
14th and 15th of May.
It's in May.
At the Royal Armouries. I've done my research.
I wasn't expecting that question. Yeah, I mean, we're down there supporting the industry as we did last year. Last year, I got the opportunity to speak on behalf of NAPIT, and I joined James on some safety panels and what have you. But it's just so that any contractors or technicians working in that environment, they can see that there is a trade body that does understand their, their sector really, because the traditional sort of competent person schemes are very sort of for fixed installations, not so much for temporary. So what we've got, our training package and what we've got available, very much suits that industry. And it's a great couple of days out. If there's a lot of hardware there, isn't there? You know, and
it's a bit like an Alexa, I think, for entertainment and events.
Yeah.
So it's you get a lot of sound equipment suppliers, lighting suppliers, and similar, all punting their wares. So for those who are not really in the industry but looking to get in, it's worth going and getting a feel for the hardware that's used and so on.
Yeah, so well worth checking out if you're in that area. 14th and 15th of May at the Royal Armouries in Leeds is Plaza.
Then the main Plaza show is in London in September.
Yes, yeah.
So that's the bigger one.
Yeah, the main event, which I'm sure we'll also be attending. There'll be more details about that and all the events we're doing as NAPIT across this year as we get a little bit closer as well. We may just have time to squeeze in one or two more questions. This one just come in. Should SPDs be used in temporary installations? And if so, how should they be used?
What was the next question?
We were talking about this earlier because it's a big topic, and without having the regs to hand, you've got your bullet points there, and if it could affect one of those, you have to do it with the 18th edition. So if you add an interruption of commercial activity,
I think pretty much all events would fulfill the requirements of commercial activity, large number of co-located individuals and so on. So you would think you'd have to fit surge protection, but it's worth remembering where the surges come from. And that is from things like lightning strikes and switching of high voltage networks. So if you're in a field and you're running off a generator and the cable's lying on the floor, then you won't get those switching artifacts. So it's down to the designer of the system to look at the risks and decide if they want to install SPDs or not.
But if you had a safety critical circuit, say a distro that was looking after the equipment, the video screens that would aid in the evacuation at an event, then
or the sound system.
There may be an extra requirement there where you'd want to protect, have the resilience there, so an overvoltage couldn't affect those safety critical circuits, as a minimum.
And also, you might be taking power from a building, or you might be in an arena or a venue or similar. So you'd need to think about the systems then. The nice thing about SPDs is that, unlike arc fault detection devices and similar, is they can sit on the supply. They don't require modifications to distribution units, so they can be retrofitted to a temporary system quite readily. Sure, which is good.
Okay, I think that's probably question-wise all we've got time for this evening. So thank you, James. Thank you, Paul, as well, for all your answers and for the presentation as well. If you came in late tonight, by the way, and missed any of this presentation, we'll pop a link into the NAPIT forum for you to watch it again as well. So that'll be going up in the next couple of days. Check out forum.napit.org.uk for that. And if you require any more technical support as well, the NAPIT Technical Helpline back open for business in the morning. The number's 0345 543 0330, or you can ask your questions through the forum at any time as well. Either ask the technical team from NAPIT on there or ask the forum for advice. It's all there for you at forum.napit.org.uk. Plenty more webinars on the way across the rest of this year as well. We'll be hearing more about surge protection in a couple of months' time, and we'll also be hearing a little more about Trustmark in the next couple of months. So do keep an eye on your email inboxes for the invites to those as we have them as we head through the rest of the spring and into the summer. And plenty of events going off as well with NAPIT across the rest of the year, including the technical road shows, which I think kick back off again in earnest in April time, Paul, back on the road.
That's it, yeah.
And the trade association meetings going off as well at the minute. So if you want to have your say about any industry issues that are affecting you, or find out a little bit more about how NAPIT are trying to improve the industry, then do find your nearest trade association regional meeting. We've had the first one last night around here in the East Midlands, but there's still 9 to go before the end of the month. So go to napit.org.uk, click on the trade association section, and you'll find your links there to follow through and register your interest for the meetings across the rest of the month. But for now, that is about it for this evening. So thank you again to James and to Paul.
Thank you.
And do enjoy the rest of your evening.
Thank you.
Good evening.